Hi, Matt Roscoe here at the University of Montana with a short video on how to construct the angle bisector using the properties of a rhombus. Okay, well let's say we have this angle ACB that we want to bisect that angle. In other words, we want to find the line that will cut that angle into two angles of equal measure. Some sort of a line like right in here. But we want to do so using logic rather than measurement tools. So we know that the the diagonals of a rhombus do indeed bisect the angles on the interior of a rhombus. So if we can somehow construct a rhombus here, then the rhombus will show us exactly, I guess, construct a rhombus with this angle being one of the interior angles of the rhombus, then that particular rhombus will show us exactly where the angle bisector should lie. So I've purposely given you an angle where the lengths of the two legs that define the angle are different in length. And that's just to sort of impress upon you the fact that you only need to really know one of these lengths, or pick any length really, to construct a rhombus. So what I'm going to do, I'm going to go ahead and set my compass to be this length C to B. I'll go ahead and scribe in an arc. And so what I have so far are two lengths of a rhombus. I'll go ahead and call this point here, I don't know, ABC, we'll call it D. So now if I can just find a point out here, E, that's the same length from B as it is from D, as D is from C and B is from C, then I will have the rhombus whose diagonal will be an angle bisector. So I'll put the point of my compass on D and scribe an arc. That's a set of points that are the same distance from D is from C, as well as C is from B. And then when I put my compass point on B and scribe an arc, there's a set of points that are the same distance from B as C is from B, as D is from C, and as D is from this arc. And so this is the point right here that's the same distance from B as it is from D, and copies the lengths here. So it appears to me that this particular point right there, let's call it ABCDE, point E would be the necessary point to create my little rhombus. So there is a rhombus whose sides are all equal in length, has the characteristic diamond shape of the rhombus, of course. We could say something like this if we wanted to. Those are all the same. And so from what we know about triangle congruence, we've proved that this particular line here is the angle bisector, and these angles here and here will have to be congruent. Of course, the argument there is one of side, side, side triangle congruence, top and bottom there in the drawing. So that's how you construct an angle bisector using the rhombus method, and I hope you've enjoyed this video.